This is problem number 6 on the practice problems for test number 2. Person throws a stone in the air. The height of the stone h in feet and the time since it was thrown t in seconds are related by the equation h equals negative 16 t squared plus 40 t. A, what is the height of the stone after 2 seconds? So the value of 2 here is a value of t. So all we need to do here is plug in t equals 2 into our equation. So let's try that. So the equation says h is negative 16 times t squared, but now that t becomes 2. So it's 2 squared. Plus 40 times t, but this t also becomes 2. You can use your calculator, but these numbers aren't so big. I think we can handle it. Negative 16 times, we do the power first. Exponents come before multiplication. 40 times 2 is 80. 16 times 4 is 64 with a negative sign in the front, plus 80. And we end up with 16 as our answer. And again, the height is in feet, so that's 16 feet. After 2 seconds, the height of the stone is 16 feet off the ground. Part B, when does the stone reach its maximum height, and what is that maximum height? So the graph of this thing right here, we should know the name of it, and we should have a sense of what it looks like. So it's called a parabola because of that t squared. And does this parabola open upwards or downwards? Well, because it's a negative 16 in front of the t squared, it opens down. So this parabola looks something like this. And that's comforting because that's kind of what objects do when you throw them up. They come back down. And we're looking for the highest point, the maximum height. So this point right up here is the point that we're interested in for part B. And that point has a special name on a parabola. It's called the vertex. So how do we find the vertex? Well, we use a little formula that tells us exactly where the vertex is. So our little formula was the x-coordinate of the vertex is equal to, it's a fraction, it's negative b over 2a. Okay, we don't have x in this problem, we have t, so let me change that to a t. I'll just actually cross it off and change it to a t right here. So the t, the coordinate of the vertex, is negative b over 2a. So let's plug in. From this equation here, we can see that a is the number in front of t squared, negative 16. B is the number in front of the t, that's a positive 40. C doesn't matter to us, but it is a number. And because I don't see a constant sitting by itself, that number must be 0. So plugging those into our vertex formula here in the bottom, it says negative b, so that's negative 40, divided by 2 times a, 2 times negative 16. So that's a negative 40 over negative 32. The negatives cancel. We just get positive 40 over 32. I'll reduce it. You can just type it into a calculator at this point if you want a decimal, but 8 goes into both of these. So it's really 5 over 4. And with or without a calculator, hopefully we end up with 1.25. So that is the value of t, which is measured in time, which is a measure of time, and so that must be in seconds. So this ball goes up for 1.25 seconds, and then it's going to come down. So that's when the stone reaches its maximum height. We're also interested in knowing what is the maximum height. So in order to find the maximum height, we take our 1.25 seconds and plug it into our circled purple equation. That's the equation right there that tells us the height at any time. So to find the maximum height, or maybe I'll put a little subscript here. This is the height at the vertex is equal to. So using that circled equation, negative 16 times t squared. But instead of t, it's 1.25. That's what we just found. That's squared. Plus, again, going to the top equation, 40t, 40, and now t is still 1.25. So this is what we need to calculate. I'll grab the calculator here. You should do the same, and let's see if we get the same answer. So we're typing in, what do we have here? Negative 16 times, I'll put parentheses, although technically we don't even need them, 1.25 squared plus 40 times 1.25. So we get a height of 25 in this case. And the height was measured in feet, so that's 25 feet. Moving on to part C. When does the stone hit the ground? Okay, so if you're looking at the moment where the stone hits the ground, then you know something is special about, is it H or is it T? Well, it's H. You know that the moment the stone hits the ground, H is equal to a certain number. H is the height, so the height is 0 when this stone comes back and hits the ground. So we're going to set the height equal to 0, again going back to our original purple equation right there, circled at the top. So I'm going to copy that down below. So negative 16t squared plus 40t, that was our equation for h. But here, instead of h, we're putting 0. Everything else gets copied. And look, it's a quadratic equation for us to solve. You're welcome to use the quadratic formula, but because there's no constant term over here, like there could be a +7 there at the end, because there's no constant term, it turns out it's quite easy to factor any quadratic equation when there's no constant term, because you can factor out the greatest common factor from all the terms. So what goes into 16 and 40? Well, let's see, I guess 8 goes into both of those numbers, so I'll factor out an 8. But more important than that, what goes into t squared and also t? And they both have a single t in them, at least a single t. So we're going to factor that t out of both. That's the important factoring. So if we factor 8 out of negative 16, we're left with negative 2 t squared, but we factored out one of the t's, so we still have one left, plus 8 coming out of the 40. 8 goes into 45 times. There was a t next to the 40, but we factored it out next to the 8, so that's it. And now because this thing is equal to 0, maybe we should have stressed, actually. Not we, but I should have stressed that the only reason we didn't have to do any more work at this stage when I started diving in with my factoring is because we happen to have a 0 there. Quadratic equations, almost all the time you're going to want to make one side equal to 0 before you do anything. And so I just want to highlight that it was important that there was a 0 there. Okay, so now because it was a 0, we can split this thing up using our 0 product property. So either 8t is 0 or negative 2t plus 5 is 0. If we divide both sides of the first equation by 8, we get t is equal to 0 divided by 8, but that's just 0. And on the other equation, subtract 5, divide by negative 2. Those negatives cancel, so it's really just positive 5 over 2. As a decimal, that's 2.5 seconds. So what does that mean? It means that the object starts on the ground. That's the t equals 0 that we found first. It's not an object, it's a stone. Stone starts on the ground at the beginning of this experiment, as opposed to being thrown, say, from the top of a roof or from somebody's arm 6 feet off the ground. And then it goes up, and then it comes down, and then the stone lands 2.5 seconds later. Okay, so we're done. We've got our answer. 2.5 is what we're after for this one. Turns out if you're really on the ball, there was a shortcut to help us answer this question, given some of the work we had done already in this problem. So let's go back up. I drew this picture of my parabola up here at the top. It was a very rough sketch, but I actually knew that the stone started on the ground because the c was equal to 0. Right? If this was a +7, then that means actually the stone is up here at 7 at time 0. And so then it would go up, and then it would come down, and it would hit somewhere out there. But I knew that this stone started on the ground because the constant, the c, was equal to 0. And actually what that means then is that if you know how long it takes to get up to the vertex, which we did, we'll circle it, or we'll highlight it here in green, we knew that it took 1.25 seconds to get to the vertex. So from here to here, going to the vertex, turns out is 1.25 seconds. We found that. But because it starts on the ground, how long do you think it takes from the vertex to get to the other point, to get to the place where it hits the ground again? Well, if it took 1.25 seconds to get to the top, then it's going to take another 1.25 seconds to come back to exactly where it started. So how long does it take before it hits the ground altogether? Well, 1.25 plus another 1.25 is 2.5 seconds, which is exactly what we got down here doing all this work. We had to solve the quadratic equation, factored, and we got there in yellow, 2.5 seconds. So I don't want to say this is like a great shortcut to carry with you all the time. It only worked because we recognized that the stone here started on the ground. If the stone started 7 feet off the ground, okay, sure, it's still going to take 1.25 seconds to get to the top, and then another 1.25 seconds to get to the same height that it started at. But that's not what we're interested in. We're interested in when it hits the ground over here. And I don't know what to do with the 2.5 seconds that we found for it to come back to the height of 7. That doesn't help me calculate the actual number I'm interested in, which is way out here. So the standard way to do it is the way we did it first. Write down your quadratic equation and solve it by some means.